Today we're going to be looking at problem number 7 of homework number 7. So problem number 7 starts by saying it gives us this z function, which is in these terms right here. It's written as this long function. So you see we're going to be like n not 1 in terms of t cosine all of a temporal aspect times an omega plus a theta, all right, plus n not 2 in terms of t sine sine of similar term as here. Okay, we are told that the theta is uniformly distributed within the region from 0 to 2 pi, so all around the circle. We are also told that the two n functions are wide sense stationary, or WSS. Okay. Finally, we're told that the two n functions and theta are all independent of one another. And problem 7 has two parts. It basically asks us to find the e of the z function, as well as find the RZ, or the autocorrelation. So let's start by looking for the mean right here. Okay. So we set all this right here. We're given these two functions at WSS, which means that basically that their expected averages we can denote like this, as here, as constants. Okay. When we actually calculate our estimated average for a z function, we plug in our function first and foremost right into the equation, right into the formula. We can see by basic arithmetic how we can actually break down and break it into two parts, find the average of this part, and find the average of this part, as we've done right here. All right. We can further break it down by taking out the n functions from each term. As we set up here, this is equal to a constant, n1 in case of the n1 function, or n2 in terms of the n2 function right here. Once we do that, we have to basically, based on the formula, we use the integration formula to actually figure out the average, like we always do. All right. We can take out constants. So the formula for the integration of this has 1 over 2 pi in it. We can take that out. We can take this as a constant. And we can also do the similar for this term right here. So as we can see here, we're integrating from 0 to 2 pi over cosine. So that's over the entire wave or circle, whatever, over the entire period, in which case what we end up with, this term ends up being 0. And similarly, because we're going over the entire wave, this goes to 0 because it's from 0 to 2 pi. So we're multiplying pi and 0 for both these, so this whole thing ends up being 0. So our expected average for our z function is 0. Now, to figure out the RZ, or autocorrelation, in terms of the two time functions, and we have to find if this is wide sense stationary, okay, if the z term is. All right, this gets a little bit long in terms of arithmetic, but basically we're following the same equations we always did. The way we actually find the RZ is by actually taking expected value of RZ at time 1 and take expected value of the product of z at time 1 times z at time 2. So we actually plug in our formula right up here, and what we do is do the arithmetic. So inside the actual big brackets, this term times this term, plus this term times this term, plus this term times this term, plus this term times this term. And now we gets a little hard to read, but this is our next term, all of it right here. Okay? You get this on this side. This times this ends up being that right there. All right? As we can see, similarly, this times that ends up being this. This times this ends up being that. And this times this ends up being that. Alright, so what we do is do some basic arithmetic. We could actually break down the e function for these two terms right here, because as you can see, the e just specifically of the n1 and n2, the product of the n1 and n2 function, is just basically the autocorrelation in terms of, looking at the wrong term, of the two n1 functions is actually the autocorrelation in terms of n1 with regard to tau. What tau we actually use as a substitution, it basically means the difference between our T1 and T2, which we're going to use as we continue on. We're going to use tau to indicate the difference. Okay? So that's just corresponds to this term right here. On the other hand, if e to this term right here, keep looking at the wrong thing. This term right here, the product of the two cosines right here, we bring down. Similarly, we can bring down, because these are constants, we can bring them down and bring them outside the function. N1 and 2. We can see how we can actually see the product of these two trigonometric functions. Do similar function right there. And again, similar to here, we can see how this term right here corresponds to the autocorrelation in terms of the n function. All right. Now, if we continue the arithmetic, we can see, I'm not going to get through all of it because it gets a little complicated. All right. But basically how these two functions here, it's basically when we do the product of what's on the inside, it's going to be adding the two insides and then subtracting two insides. Subtraction of the two insides, yeah. And all over 1 over 2 pi. And here we have the actual addition of the two ends right here. See? We add these two terms, these two, that cosine. And here's when we do the subtraction, all right? This minus this. As we said, the tau is going to indicate the difference, so it's going to be W out of tau, and the thetas cancel out. That's going to be this term right here. As I said, we can actually bring out the autocorrelation in terms of N1. The two inner terms actually break down like this, as you can see. Okay. Now, these two terms, actually, these two integrals, this inner term for both of them, which is the same, okay, this ends up being basically 0, these two terms. We can see it. I'm not going to go through how the derivation, because I want to make this point. This is going to end up being 0. These two integrals are almost going to be exactly the same. The only difference is going to have a difference in the actual, this one's negative and this one's positive. These two functions are going to cancel each other out because they're exactly the same. The only difference is in their whether they're negative and positive. So these two cancel out. Our final term is going to be similar to this term right here. All right. Again, we bring out our autocorrelation in terms of N2. All right. The arithmetic continues up here, and what we end up with, sorry, it's a little funny to read that way, but what we end up with when everything's said and done, when we integrate this right here, we're going to end up with 1/2 r sub n1 in terms of the difference of the times, plus r n sub 2 in terms of the difference of time, all that divided by 2, as I said, times the cosine function in terms of the difference of the times with the omega regulator. And that's going to be what our RZ is in terms of the two terms, the T1 and T2, which we designate here as just the difference. I mean, we could have equally have written this RZ T1, T2, but we just designated it accordingly. And as we can see, the actual function is definitely WSS. Finally, we're asked to actually just find the value of the term. If it is WSS, just plug in 0 for our tau, which we do. We basically take this function here, bring it down, plug in 0. This ends up being 1. And as we can see, at 0, this ends up being basically e to the n1 squared term at t plus e to the n2 squared term at t. And that's the end of problem number 7.